So now let's take a look at this thing called the second derivative test for local extremis. So now we're using the second derivative to determine if a function has a local maximum or a local minimum at a specific point, which we know as critical points. So if you find the critical points, so right here, if you find the critical points, first option, the second derivative at that critical point is less than 0. That means it is concave down, like this. Then it's a local maximum. Makes sense. If you have a critical point and you find at that critical point that it's concave up, like this, means it's going to go from decreasing to increasing, then that means that it's got a local minimum. Okay, so that's the second derivative test. Pause the video as much as you need to kind of absorb what that means. But we're going to go ahead and move on to an example. So use the second derivative test to determine a local extremis. So we have, first of all, the first derivative. If you want to go ahead and try this on your own, find the second derivative, come back, see how you did. So the first derivative is going to be 3x squared plus 6x. All right, we're going to go ahead and stop there, find the critical points because we need to. So we're going to set that equal to 0. So you would have, let's take the 3x out, and you'd have x plus 2 inside. Set that equal to 0. You would have x is equal to 0 and negative 2. So those are our critical points. Now we're going to go ahead and find our inflection points. So we find the second derivative, that would be 6x plus 6. We set that equal to 0. Whoops, 6x plus 6 equal to 0. And we would find that x equals negative 1. Okay? Now, we're going to come back to what this means. I guess we didn't necessarily need to find our inflection point. All we needed to do was find the second derivative because we can use the second derivative test directly, but I'll come back to this inflection point to show you what that would look like on our number line that we used for the first derivative. So first of all, here's the second derivative. Okay? We plug your first critical point, which is 0, into your second derivative. When we plug that into our second derivative, you would get 6 times 0 plus 6, and we get a positive answer. Again, we don't care what the numerical answer is. All we care about is if it's positive or negative. So this means it's concave up at that point. So then that means if it's concave up, the graph looks like this, and so our critical point's down there. That means that it is a minimum at that point. So minimum at x equals 0. Second derivative at this critical point be 6 times negative 2 plus 6. Again, we don't care about the numerical answer. All we care about if it's positive or negative. So we get negative, so it's concave down. So our critical point falls in a graph that looks something like that. And we know then that it's a maximum at x equals negative 2. All right, so that's what the second derivative test is. It's really easy. You don't need to graph. You don't need to do the number line. But again, I'm going to tie this in just real quick. If you're done with this, fine, shut off the video. I'm just going to tie this in really quick. We're going to put our critical points, which were negative 2 and 0. And then this right here, again, halfway between them is our inflection point. So it changes inflection here. So really, all we need to do is determine from negative infinity to negative 1, then from negative 1 to positive infinity, we need to determine if it's concave up or down. And we determine that at 0, it was concave up. So if it's concave up, then that means it goes from the concavity changes. So it might look something like this, our graph. I should really do that in a different color since I have all these colors. Here's our maximum, we know that, our minimum. So then that means at this point it changes concavity. In our graph, if we look at the graph, it should look something like this. Okay, so again, finding that point of inflection is really going to help us when we come and have to sketch the graphs of the first, second derivative, compare that to the original function or whatever. So the green is the original function, and the blue is the second derivative, and the red is the first derivative there. Gives our max and mins. All right, so I think that's all that I have for you, the second derivative test. Fairly simple test, really useful, especially when you don't necessarily have a function or the original function. You just have the second derivative and you need to use that. Maybe you have the critical points, whatever, but you definitely need to know this technique for the AP exam.